So now the last thing we have to do. So now we have solved for the reduced pressure and the reduced temperature. So we have to get a value for Z, and we are getting that on this property table. So this is the value for compressibility with respect to what this is, the critical volume. So that is the property for the critical volume. Now with respect to what? Reduced pressure. So, and in this case, we could still relate that to, because it tells us that we can be able to get the value for compressibility by just making sure we look at the reduced pressure. So this formula is applicable. We see that we have reduced pressure with respect to pressure and the critical pressure with respect to CR, which is what we've been talking about for the reduced temperature. So now I'm going to look at the value for my reduced pressure, which I have is 0,246. I have 0,246, which is, I look for 0,2. So 0,246 will be around here. So now I'm looking for I'm moving this up, and I'm looking for what? I'm looking for a point of, remember this gives me my value for what? My value for reduce, my value for what? This value now is my value for the reduced temperature, which is 0,863. And because I have, this is 0,85, therefore I'll have around here, I'll have 0,86. So I take that point here. Then I can have this point here can be equal to my what? Can be equal to my Z. That Z now can become approximately, let's say, if you take my graph here, I'm getting something close to this. I want to draw a straight line. Let me say it's actually 86. So 86 is going to be a point. Let's say we have something around here. So remember, a graph will not always be accurate, so I'm trying to get this point for the reduced pressure. Yes, 0,246, and this has to be 0,863. So this is going to be somewhere around here. When I draw the line here, I can take any value around 0,84 or 0,85 or 0,86. So any value of this range will be accepted, and therefore I can say my Z is equal to 0,84 or 0,85 or 0,86. So the graphical method has more error, and therefore the Z now becomes what? becomes Z 0,84. And can we determine the specific volume? Yes, we can determine the specific volume. So this is actually Z. It's actually Z. Can we calculate the specific volume? Yes, V is equal to what? Is equal to Z and V ID. So this is equal to what? 0,84 times 0,026325 meter cube per kilogram. So in that case, we can have the answer for specific volume to become what? 0,02213113 meter cube per kilogram. So we have a percentage error of about 2%, which is accurate for both of the specific volume. So that's how we do this problem. So God bless you. Have a good night. Bye-bye.